Welcome to another video. Today we're going to talk about the VSEPR model, otherwise known as VESPR or VSEPR or something like that. It is the model that helps us to understand molecular geometry. So the shapes of molecules, the shapes of covalently bound things. So the valence shell electron pair repulsion. Valence shell, so we're talking about the valence shell electrons and how pairs of them are repelled by one another and will distribute around a central atom. The structure around a given atom is determined principally by minimizing electron pair repulsion. So if you push pairs of electrons together, they'll push away and try to be opposite from one another in some way. So we're going to predict VSEPR structure based on what we have. So the first step is to draw the Lewis structure. You have to have the Lewis structure of those molecules. So put the pairs as far apart as possible, but this means in 3 dimensions, not just on paper. On paper, you'll get the wrong shape if you just do it 2-dimensionally. You have to think in 3 dimensions and distribute things in 3 dimensions. Determine the positions of the atoms from the way the electron pairs are shared, and then determine the name of the molecular structure from the position of the atoms. So we name the electron geometry and then we name the molecular geometry. So with one atom bonded to another atom, it's one linear thing. It's just a line between the 2 points. If the steric number is 2, so this means there's 2 atoms or lone pairs or a combination of 2 bonded to a central atom. So we can have 2 atoms on a central atom or an atom and a lone pair on a central atom. Steric number is 2. This is always going to be linear as well. They're going to try and get as far away from each other as possible. Steric number of 3. So this means 3 atoms or a lone electron pair or a combination of 2 lone pairs and a bonded central atom. So this is called a steric number of 3. If they're all atoms, this is trigonal planar. If it's 1 lone pair, we're going to get a bent or angular shape. If it's 2 lone pairs, it's going to be linear. Now the electron geometry is still, the electrical geometry is still going to be trigonal planar, but the molecular geometry is linear. Steric number of 4 is tetrahedral. So electron geometry or electric geometry is tetrahedral, but if there's 4 atoms, that's also a tetrahedral molecular geometry. Once we lose one of those as a lone pair, we get a trigonal pyramid, and then 2 lone pairs is bent or angular, and then 3 lone pairs back to linear because there's only 2 atoms there. Steric number of 5 atoms or lone pairs or a combination of those bonded to a central atom. Steric number of 5, this doesn't happen very often. 4 tends to be about where we settle in, but there's a few possibilities that are higher. 0 lone pairs, it's called trigonal bipyramid. It's a triangle in the middle with 2 on either side, trigonal bipyramid. We get a seahorse, sawhorse, or seesaw shape with 1 lone pair. 2 lone pairs gives us a T shape, and 3 lone pairs is linear. Steric number of 6. 6 atoms or lone electron pairs or a combination of the 2 bonded to a central atom. So this gives us an octahedral shape, or with 1 lone pair, a square pyramid, or 2 lone pairs is square planar. 3 lone pairs, it gets weird and you can get some other things happening, T-shape and such. So steric number of 7, possible. We get 7 atoms around, steric number of 7. A pentagonal bipyramidal or a pentagonal pyramid with 1 lone pair. These don't happen very often at all.